Hi everyone, we're Team B, but we're about to present you with an A-grade solution. Sydney's water is expected to be sufficient until the year 2025. After that, the population is expected to grow significantly over the following 25 years, with the water demand potentially doubling in that time, compared to what is currently being used. That's less than 10 years before we have a potential large-scale water shortage. Water is essential to life, not only to sustain us as a drinking source, but also for so many other practices. How can we address this shortage? How can we ensure that the City of Sydney and its population will have enough water to survive? What unknown water resource is yet to be considered?
So we look to nature as our architect for solutions by analysing how it sources water in different environments. So let us take you to the dry and arid Namibian desert. In this harsh environment, we found our inspiration, the Namibian beetle. The survivability of this tiny native bug in such a large dry climate is solely dependent on its ability to source its water from the atmosphere. During the morning fog, the beetle will tilt its body so that the morning fog passes over its forewings. The little water-attracting bumps on its forewings then condense the water from the atmosphere, and the waxy water-repelling shell beneath the bumps will channel the water back to the beetle's mouth. This amazing nature's architecture has created a vision for us to harness the water from the atmosphere. We have applied these concepts across 3 different scales: industrial, commercial, and regional.
On the industrial scale, we've looked into thermoelectric power plants such as the coal-powered ones used in New South Wales. These power plants use a significant amount of water in generating electricity. On average, Australian power plants use 1.5 megalitres of water for every gigawatt hour produced. To put this into perspective, American thermoelectric power plants use twice the amount of water that flows over Niagara Falls annually. Our idea is to recapture some of the water that's lost through evaporation. We looked into cloud seeding as an option to recapture this water. Cloud seeding is a proven technology whereby the induction of silver iodide particles helps form water droplets that then fall as rain. We've looked into porous pavement to then capture this rain. The porous pavement is to be around the whole facility. This porous pavement is a permeable pavement which allows water to go through the pavement whilst filtering it on its way. The water that is then filtered will be pumped back into the facility, thus reducing the strain on traditional water resources.
We then looked into applications that is possible on a commercial level. I'd like to draw everyone's attention to the fact that one of the main reasons that we're all feeling so comfortable in this room right now is because of the right ambient temperature set by the HVAC settings in this building. Cooling towers. In this building and many other commercial buildings are using up to 30% of the total water inflow into the building in order to maintain a comfortable ambient temperature. On top of this, 88% of this inflow is being lost to evaporation at a rate of 12 litres every minute. This is because cooling towers work by passing air through hot water in order to dissipate heat through evaporation. Once this water has been evaporated, it's pulled out by fans and released to the outside air. So we thought, why not capture this water vapour and condense it? So this idea incorporates a few water condensing techniques sourced from both nature and technology. Firstly, we would circulate refrigerant through the blades of the fans in the cooling towers that pull up the water vapour. This will cool down the air as it passes over the fan and cause water to condense onto the blades. Then, as the exhaust moves further up, it will pass through multiple layers of spiderweb-like structures that mimic the way spiderwebs in nature capture water from the atmosphere. Finally, the exhaust will meet with the inner walls of the chamber that mimic the Namibian beetle's exoskeleton and capture any excess water still left in the exhaust. The captured water can then be recycled back into the cooling tower system. A 20% recapture using this method can pull in 1.26 megalitres of water every year for every cooling tower, and there are 5,000 cooling towers registered in the wider Sydney region alone. So this amount of water can actually provide 34,500 households in Sydney with water every year.
On a regional scale, we propose to extract water from the air. There's a lot of water in the air, and it is the only source of water regeneration in nature. Having said that, most of our drinking water at the moment are sourced from Warragamba Dam. Our idea incorporates atmospheric water generators, or AWGs, that condense water from the air and also purifies the water through filtration and disinfection. The system can provide 10 kiloliters of fresh water per day, and the power requirements can be sourced from solar panels. And the solar panels can be the floating solar panels, such as the ones on Warragamba Dam. This system can significantly reduce the amount of water lost through evaporation. And in 2012, this number was 25% of the total water inflow into the Warragamba Dam. So this system can provide almost 600 atmospheric water generators with power, and by covering 1% of the Warragamba Dam surface. And the total water supply to Sydney can be supplied to 14,000 of household to Sydney. And the great thing about this technology is that it can also be used for small-scale water generators. And this small-scale water generators can provide 20 liters per day of water to the residential houses. And the water can be stored in clean water tanks, and it can also be used for other domestic purposes. With the improving solar technology, this solar panels on residential rooftops can be enough to provide sufficient amount of power to this atmospheric water generators.
Nature has proven that condensing water in the atmosphere is a viable water source to sustain life. We have shown by tapping into this unharnessed water resource, it can be applied across many different scales. We believe that this is a diverse solution which has many different applications, some of which we have shown today. What we have shown you today would provide enough water for more than 50,000 Sydney households every year. We believe that Sydney's future can be about sustainable water usage using technology inspired by nature. Thank you.
Thank you very much, challenging our water resources team. I'll now just go to the judges and ask them for a couple of comments. And I wondered, Stephen, if you might start with a comment on the challenge presented.
So I thought that was a very interesting and engaging presentation. So well done to Team B. I really liked how up front they set the scene for the challenge. Thought that was really, really powerful. The idea that we've actually, right here, right now, it's not a huge problem, but come 10 years, it's going to be a big, big problem. So I thought that was really very effectively done. I really liked the mixing of some really interesting data and some really powerful metaphors, and trying to sort of bring that back to really talk about this impacting 50,000 households, or the idea that this would 5,000 cooling towers. There's some nice data and there's some nice metaphors, including the Nambian beetle. So I liked all of that. And it certainly got me thinking about sort of how we can use existing processes and systems to better effect. So there was, I think, in the summary, a lot of diversity, a lot of sort of lateral thinking. Whether or not we sort of saw some really sort of out there, new, innovative thinking would be probably my challenge to the team, or whether or not it's sort of packaging up a different way and a more innovative way of using existing technologies and existing processes would be, I guess, the challenge to the team. But overall, really good job.
Okay, great. Thanks, Stephen. Any other comments from someone on the panel? Lucy?
What I didn't really get a very good understanding of was the scalability and the cost. It was a terrific presentation, but when I thought of 50,000 dwellings, that's a lot of dwellings. But in the overall scale of Sydney's future population, I was worried that wasn't really going to get us far enough unless the solution was much more scalable. Yeah. But it was outstanding. Thank you.
Okay. Great. Well, thank you very much to Condensing our water resources team.